Hi everyone. I want to have a look at coordinating a site model with different disciplines models, specifically shared coordinates and how one handles them here in the Southern Hemisphere. One must always remember Revit was created for the Northern Hemisphere with the Northern Hemisphere in mind, and we work a little bit differently here in the Southern Hemisphere using it. So on my screen what you can see is that there is a survey beacon which is at the origin here in AutoCAD. Typically in South Africa, where we live here in Cape Town, that would be WGS 84 low 19, and so this is a position somewhere on the geoid of the planet, and basically it's a mapping that then pretends that the Earth is flat and that we've got a latitude and a longitude measured linearly, in this case in millimeters. Therefore you can see this is almost, make it 90 kilometers to the west of the marker, and over here that's almost 85 kilometers to the south of the marker. The marker itself I've indicated in blue. There's no geometry over here, it's just there to illustrate that it is there. And then over here is where the project is located. And as we zoom in, you'll see that there is the site drawing. There's some references over here giving the latitude and longitude. And then there's two yellow lines, a vertical and a horizontal, which is seemingly random, but that I've created in a specific way. The reason for that is often one only has a surveyor diagram which would give one the corner points of the property, but there would be no information with regards to the contours that you can see running across the drawing over here. So typically these contours would not be there. One would then have to go and contract a surveyor, perhaps use a drone with photogrammetry or even a laser scan to help build up that surface. So far so good. In this drawing those contours were included, and what I did was I used the measure tool to go and divide those contours up into points, after which I extracted the data from the points to give me a points file X, Y, and Z. That's also why you'll see that my points file corresponds to the heights given here or annotated here in meters. Typically they wouldn't, they would be any value whatsoever. It would just be grabbed from a points file, and the Z wouldn't be ordered into neat sets. This is a three-dimensional file. This is not the final file that we will be utilizing, but it does serve to illustrate that when we do eventually create the Revit surface, that we'll be able to check it against the contours that are shown here in 3D. So that is how this file is put together. It's there to illustrate some concepts, and we are going to see how that operates or how that works in Revit, so that we can start setting up specifically how to coordinate a points file with the CAD file. Partly the reason is because Revit does not handle creating geometry far away from the origin very easily. It really doesn't like things that are further than a mile, or even 22 miles for that matter, and this is a little bit further than that. On the other hand, I've drawn the solar system to scale in AutoCAD with really great results. So AutoCAD and Revit, really two different beasts. Revit doesn't handle distances very good at all. And remember, Revit has a project internal point, which is in addition to the project origin and the global origin. Those are the three UCSs. The one you can't change at all. It's always just at the 000 point of Revit. It's a project internal point. You don't see it. It's not annotated in any way. I'm going to create to create a new project from our South African architectural template. And I'm inserting the CAD drawing as a link. Remember, don't insert CAD files or import CAD files unless you mean to explode them. And I'm going to go to my shared directory to CAD data, and I'm going to bring in that file. And what I'll do is I'll place it, first of all, so it's visible in all the views. Sorry about that. It's visible in all the views. And then I'm preserving all of the colors. There's all the layers. I know that this file is in millimeters, so I'm going to import it in millimeters. I'm not going to autocorrect anything. And then when I place this file, I'm going to place it manually by base point. Basically, it just allows me to move it into position. Now, immediately you'll see I get a error. It's more than 20 miles away from the origin. That's fine. I'm going to continue with this, and then I'll zoom out. I'll zoom out a little bit so that you can see there is the file. Okay. In this case, it's not going to work very well from in my level 1. I'm going to go to my site level, and let's import it from here instead. There we go. Link Revit from our shared link CAD from our shared CAD directory. All the settings are still the same, and in this instance I can see the marker, which is going to make it easy for me, or relatively easy for me, to place this better into position. So it's somewhere over there. Then I'll zoom in closer. Select the link and move from this yellow line top one. Move from this yellow line, intersect directly onto the, so unconstrain the movement directly onto the project base point, which coincides with the 000 point, the project internal point of Revit at the moment. All right. So how did we get to these yellow lines? I drew these yellow lines up in CAD, and I got it in the following way. I'm now going to switch over into Excel and just demonstrate quickly what was done. So initially I created a point extraction giving me the X values as highlighted on the screen over here. There's quite a lot of them. And then there's the Y value, the Y values, and the Z values. And what I've done, because it's so far away from the 000 point, is I've created a calculation here which is going to center the points. It's going to calculate exactly what is the center of the points in X and in Y. And how I do that is I first of all calculate what is the minimum value. There you can see it's calculating the minimum value in this column, the minimum value for all of the X values. What is the minimum X value that all of the X values have? There's also a maximum value for X. And then there's the midpoint of X. So it's halfway in between the maximum and the minimum. So we add the maximum and the minimum together and divide that by 2. We do the same thing for Y and for Z. Although for Z, we're more interested in the minimum value. So after this is done, I subtract from the x values, the midpoint of x. In other words, the middle point of all of the points. What is the x middle point of all of the points? And the same thing with y. I subtract that from y, and then from the z values I simply subtract the minimum. So in other words, I'm moving all of the points over the origin and down towards 0. That's a transform that I'm applying to all of the points. What I'm doing next is I'm importing them into a sheet within Excel for itself, position X, position Y, position Z, just to give me a reference. And then once that is done, one would say File, Save As, Browse, and then choose the format to be CSV, delimited. And save. Okay. Yes. And then we can close. So what has that done? That's created a comma delimited text file for me. There is the shared directory. There's the CSV file. If I open that file with Notepad, I'll see that there's position X, position Y, position Z. Now Revit has absolutely no way of understanding that. So I can delete that line entirely. And in addition, right towards the end of the file, there's a carriage return line feed that needs to be deleted as well. Revit interprets that as enter or new. If that space, if that carriage return line feed or the enter, if that is in the file, Revit will reject this file, so I can save that now. Save. Save and close. Right, so what have I got here? I've got a file that has been placed into Revit with the contours floating up in the air there. And you can see how it doesn't like orbiting this very much. Next, I'm going to generate a topography from the points. So note the following as well. The mid X and the mid Y correspond to the yellow lines. Looking at Revit, it's the same values as what you'll find here. So when I generate the points, they're going to be generated around that is the center. So massing in site, topo surface, create from points file, and now I can browse to the CSV file. I know that the file is in millimeters. And what I can do now is look to see whether the contours and the points or the topo surface that was generated from the points file correspond to one another. That is the check. And you can see this is generated around the 0, 0 at the moment. So we fix that as follows, or not fix, we investigate it as follows. We would move the topo surface up by the minimum Z value, which is 1494000. Going back to Revit, I'm going to move the topo surface up. I constrain the movement to make sure it's vertical 1494000. So there we can see an elevation that is looking good. Switch on shading, and there we can see how wonderfully this is now perfectly aligned, no discrepancy whatsoever, and that is great. So this is just to show how one can use Excel if one does have a surveyor going out into the field to go and make some measurements, how you can correlate that to the CAD drawing. One would of course just have to draw these yellow lines within CAD to make sure that one can reference it accurately, but it is doable and one can be perfectly accurate with it in Revit. In the next video we'll look at creating a more realistic workflow but using the same points file and a CAD file that has been modified slightly. Thank you for your time. I hope that you find this video helpful.